Hello everyone, this is a video about a new style crank plate for the Clay Spencer tire hammer. The purpose of this video is about the crank plate assembly. However, I'm going to talk a little bit about axles and hubs. And we've seen on the forum a few times lately some people that have built with a smaller axle. I want to just notice the size of the spindle. This is a number 84 spindle. It's made for a 3,500 pound axle. Two of these together, the 1,750 pounds rating each, form a normal 3,500 pound axle. And out here's where the seal rides. This is where the inner bearing rides, grease section, and then the outer bearing goes here. And so just note the substantial size of that. Just a few people have made the mistake of using a too small of a spindle and it is broken. So I'm going to set that aside. Talk about hubs. This is a Dexter hub, 5 on 4.5. This is what I prefer to use. It's got big beefy gussets on the back side here, really thick area here, and it works very well. This is an import style hub, and it works just fine as well. You can notice it's just not as beefy down there. It's going to work just fine as long as you put it together right, don't bind anything up, and torque everything down fine. So I'm done talking about that. Now then, I want to talk a little bit about hubs. I want to talk about lug-centric versus hub-centric. And most of us, with our cars and pickups, are used to lug-centric wheels and hub systems, right? So you can see this acorn style tapered nut. And I don't have a rim here to show you, but I think you'll know what I'm talking about. There's a tapered flange for each hole, and when you snug this nut up, that taper causes the rim to align to the center, and you get a very nice centric, and the load is transferred from the wheel, from the ground to the tire, through the wheel to the hub, to these lug centric. Now then, I grew up on a farm, worked with tractors and bigger trucks, and we had tires and rims there that worked on a hub that usually had kind of a machined boss here, and the rim fit very tightly here, and that's where the load was transferred, was here. The lug nuts still look the same. They stuck up the same except for the lug nuts. The lug bolts still look the same. The lug nuts had a flat surface on, and that was allowed to float, and it was a hub-centric bearing mechanism. The reason that's important is we're using a lug-centric hub. We're also using tires, rims that were made to be lug-centric, and we are using them in a fashion like a hub-centric. So none of it was made. We're turning the tire around backwards usually, and so I would like this to be kind of hub-centric. I would like to be self-aligning, and so I use the white spoke rims for the trailer tires, and they have a larger hole than some of the temp spares, and I have this bushing that I put on the outside here, and you can notice that it fits pretty tight. I mean, there might be about a 64th of an inch play, maybe a 32nd of an inch play there, but I'm going to, during the process of assembling this, I will press that in, and I'll press it in so it's almost flush on the bottom. It's going to protrude out about 3/8 of an inch on the top, and then I'm going to tack weld that 3 places on the back. So that is what this bushing is for. I'm going to set that around the side here. I'm done talking about that, and I'm going to get rid of the hub. So now then we have the crank pipe, the crank circle, and so you noticed that I had knocked the factory studs out of the hub, and we're going to use these grade 5 bolts here, and we're going to put these 1/2 inch grade 5 bolts in, and they're going to go in here. You want these holes, I've drilled them so that they're nice and tight, and so they're going to align good. But if you've cut them with a method that's not as accurate, you want to make sure that they're aligned properly before you do this. But I'm going to put them in like that. I've already kind of dressed these, and I'm going to tack weld these 2 places on each one. And I'm doing a little bit more than a tack weld, but I'm not doing a full-on weld. I need that to hold in tight enough that I can torque the bolts from the outside, you know, several times and not break them loose on the inside. So I will weld them up. I will also have you, if you can picture that bushing I showed you will be here, and I'll tack weld it 3 times there. And then I turn that over, and these are all going to fall out, right? But you can picture what it would look like. So I'm going to set that on here, onto the crank pipe, center it up. It'll get clamped down. Everything's going to be clamped in place. And I'm going to weld that around the outside here. It gets tack welded obviously first everywhere so it doesn't slip loose. And then 4 nice fillets on these flat spots all the way around here. Then I turn it off and I put it on my welding positioner and I weld the inside solid all the way around. Once that's done, we come to the crank plate itself. The crank plate is going to get the crank bolster. It's going to go in like that, and then the crank pin, crank bolster is going to slip on that, go all the way down, and I'm not going to put that on for now. But you can see that now we've got this welded here. That will go on here like this, and of course this has already been welded on and it's welded in place really good, and I will have a completed crank plate assembly for the Clay Spencer tire hammer.